So what is the name of the first chapter that you are able to see? Electric charges. So you are able to see this electric charges and fields. What is the next chapter's name? It is called electrostatic potential and capacitance. Right. And what is the name of the third chapter? Current, electricity. Okay, accepted. After that you have something called as moving charges and magnetism. All those things we'll see. But if you see these three chapters, right, I would say they are somehow related to one important point. Can you guess what it is? It is, I told three chapters are related to one important point. Here do we deal with static charges? The name is there, current. Current means something that is moving. Right? So if you look at the first two chapters, right, actually they are the same chapter. If they give it as same chapter, it will be very lengthy. That is why they broke it into two parts. Okay. So electric charges and fields, the name is suggesting something. Similarly, you have something called as electrostatic potential and something called as capacitance. Okay. These two chapters fall under an important branch of physics which is called as dash. Can you fill the dash? The hint is there on the board itself. You told it. Electricity.
Electrostatics.
It is electrostatics. I told you the hint is there. So he already told the answer. He used the word static charges. Right. So the first thing that we need to understand is something called as electrostatics. Okay. If I try to dissect this word into two parts. So electro refers to charges basically. Statics refers to rest. So if I am able to add these two words, I will be able to define a branch of physics itself which is called as electrostatics. So what do we actually deal in them? If there is a branch of physics which deals with the charges, when I say charges, I am talking about electric charges. When the charges are dealt at rest, you call that kind of a branch as electrostatics. Right. So if I keep the word electro same, what would be the counterpart of statics according to you from the basics of mechanics? So if I have to replace, give an opposite of static, what will you tell me? It's dynamics. So if I call something as electrodynamics, that is what is current electricity. Because here the charges are in motion. Current means what? Water current and other. When you take a river, there is a water current flow of something. Right? It's not still. Right? So current means something is moving. So this branch can also be called as electrodynamics, which is not an often used term. We generally don't call current electricity as electrodynamics. Nobody uses that word, but for us to understand. Are you able to understand? So as of now, we are not going to deal with this. We are going to stick to these two chapters. Like since this being the second chapter, we'll come back to this point. Right? Again, we'll try to dissect this and see. Electric charges. Right? You already know what are charges. Right? You have already heard this term. Right? Multiple times in your chemistry, you know what is dipole moment and all those things. Right? You already know that. But we'll try to define them. So you have electric charges, and what do you mean by these fields? What do you mean by this field? Cricket field, football field, it is an area, right? It is an area where you are able to sense something. Right? So here I use the word electric charges and fields. So actually what you are supposed to do is connect electric charges and connect electric field. Are you able to understand what I am trying to say? So we are going to deal with charges in the first place. What happens if the charges are at rest, and what is the kind of region it is able to build around itself. So for you to visualize what that region is, let me take this example. Let's say I hold this remote. Right, I am holding it like this. Right. What if I release this? It starts falling down, right? Now the question is, I want you to explain what is the science behind this phenomenon to exist. Why is it able to exist? Can you give me the science behind this? See, if it was only gravity, it should have fallen, but it is not falling. So I want you to give a justification for why this is happening. Give me in terms of free body diagram. mg, that is the weight of the object. What is supporting in the upward direction? How is it normal? Either normal. The laptop is standing because of normal. Normal is a contact force which acts from the bottom. It's not acting from the bottom. It is a tangential force. Where are my fingers? If I keep it like this, you call it as normal. If I keep it like this, you will not call it as normal. So it's a there is some tangential force acting. What is it? You are able to see. If I apply some oil here, I can't hold it. I've given you the hint. It's a friction. Right? There is a tangential force which is actually balancing the weight of this object. Right? That's the science. If I release it, it travels because of the unbalanced gravitational force, which is its own weight. Am I right? So can I explain the same scenario with a different perspective? See, what I'm going to do is, I will say this first simplest statement is this is traveling because of its own weight. Okay, that's simple for me to tell. Second, I will say this object is being pulled by the gravitational force in its own field. Meaning, surrounding this object, there is a region where it is able to sense a force. What is that region around which it is present? It is the gravitational field. It is some field, but what is the prefix you will add to it? Gravitational field. So this object is being pulled because of the presence of force in the gravitational field. Can I say it like that? It's just a different perspective. In a similar way, if I have a charge in my hand, let's see what is the charge in the next step. So if I have a charge in my hand, surrounding that charge, what will I have? I will have a region which is called as electric field. So what happens in that electric field is what the question is. That is what we are going to answer or try to answer throughout this chapter. Why are those fields generated? If at all the field is existing, what will happen if you try to do changes to it? That's it. If you answer these two questions, that's what this chapter is. Am I clear with that point? So having said that, as I told you, the first point that we need to understand is what is an electric charge in the first place. Charge is a famous term which people already know. But what is electric charge according to you? If I ask you to put it as a definition and give me a perspective to it, what would you tell me? What is an electric charge? Okay. So if I have to speak about charge, what is the kind of material I need to take as an example in the first place? What is the reference material I need to take to speak about it? Come on. Correct. It's an atom. So where does the concept of charge come from? Basically from an atom. Right? So everything is made up of atoms, right? When I talk about an atom, what does the basic of an atom speak about? It consists of a central core which is positively charged, and you give a technical name to it called as a nucleus. Around this nucleus, what you have? You have something like the circular orbits. In those orbits, what is revolving? So electrons are revolving in a circular orbit. Ignore the shape of it. Yeah, they are circular orbit where the velocity is going to be tangential to the surface. Am I right? So now the question is, I have something called as electrons, protons and neutrons. What are electrons? Negatively charged particles. Protons are positive. Neutrons are neutral. Right? Now, you know this concept that you would have learnt it in your lower grade. Like charges repel, unlike charges attract. What do you mean by like charges here? You have a positive and a negative. So, sorry, positive and a positive, or a negative and a negative is a like charge. the vice versa is going to be unlike charges. So, but you're using the word positive and negative, right? When I use the word positive and negative, where does it come from? If you bottle down to the basic, it comes from the concept of atoms. So, this atom as a whole, if I have to speak, when can I speak that it is stable in nature? When? Yes. So, can I put it like this? Amount of positive charge is equal to the amount of negative charge. I'm sorry. Right. So, what you told is right. I'm just writing in a different way. So, amount of positive charge is equal to the amount of negative charge. Makes sense? Now, what if any one of them is disturbed? The material gets charged. It becomes unstable, okay? And it gets charged. Right? So, if I talk about a material, okay, let's say it's some random material, and I say this material is positively charged. What is your understanding of it? What is it you're able to understand? Similarly, I can think of another material which is negatively charged. Think about it. When I say something is positive or something is negative, in both the scenarios, can I say that the material is unstable? Right, have that in your mind. Now, coming back to the concept of atom, I have positive and negative charge. So, if I want to make a material positive charge, I'll give you two options. I can either increase the number of protons, or I can decrease the number of electrons. Am I right? Means an atom can either gain more number of protons or lose its electrons. In both the scenarios, what will happen? There will be an unbalance in the charge where the amount of positive charge will dominate the negative. Right? So, protons gained, electrons lost. But among these two situations, which one do you think is more feasible? Which one is possible? The electrons being lost is a possible scenario. Why? Simple. You look at the diagram, you will get the answer. Where are the electrons? They are in the border. It's very sense. It will try to go and attack somewhere. Right? So what will a positively charged material try to do? It will try to attain stability by trying to go and attack a negatively charged particle. Similarly, a negative one will do the reverse. Is it clear till that step? Now the question is, whenever a material is charged, basically, what is it trying to do? It is trying to exert a force on the neighboring particles. Right? So can I say that is the property attained by a material which is charged? So what is the property attained by it? To exert a force on the neighboring particles. So if I combine everything and give a definition to it, right? It is defined like this. It is an intrinsic property. So any idea of what is this intrinsic? It is an intrinsic property due to which a material, what does it do? Exert a force on the, yes, force on the neighboring particles. Am I clear with this? So why is it proper? Who's making it happen? It is a property of the material, which is what property is the material is making it happen? It is the electric charge. So basically, if somebody asks you what is an electric charge, it is a property possessed by a material. Property is some quality that it is showing to the nature. So it is a property due to which what will it do? It will exert a force on the neighboring particles. Am I clear with this? Now the next question is, there are two questions I need to answer. Okay, sir, you told me about positive and negative charge, accepted. But how are those charges created in the first place? So is it like, are you able to see an electron, just put your hand and take it out? Obviously not possible. You cannot do that, right? So we don't see, we have not even seen how an atom looks like. This is what we are saying. We are saying that if an electron is removed or added, you are affecting the charge of a material. Question is, how can you charge that material? That is the first question we need to answer. Second is, if you charge that material, what are the basic properties exhibited by that material? Right? So first, let me explain the basic properties, then I'll explain you the methods of charging. Okay.